Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 116 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Kepler kit for Raspberry Pi Pico W. Hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And we're going to very briefly change topics a little bit from our work on the Pi QT widgets, and we're going to learn how to control a DC motor using the most excellent TA6586 motor controller. Okay, and we're going to learn how to control the speed and the direction of the motor today. So that's kind of what our goal is for today. And so let's jump over and I'll kind of show you what my circuit setup is here. Okay, you can see that if I got out of your way, you could see I've got the Raspberry Pi Pico W. I have the TA6586 motor controller, and you can find that in your kit. And to kind of give you a little heads up, a little help there, it's on the upper level in this little piece of foam with these various IC. The way you know what it is you could have microscopic vision to read the label on it, or you could see that it is the IC on that little piece of foam that has 8 pins. And so it is your 8-pin one that is going to be the right one. Now, I'll show you the schematic in just a minute, but you can also see that we have the little DC motor. We have the little fan on it. And then I'm going to be running this project from the breadboard power bank. Now, unfortunately, this did not come in your kit because the kit was developed before this board came along. But you can, I've got a description, I've got a link down in the description. I think these little boards are under $10. And the cool thing about it is it has a battery. So whatever project you do, you can go completely mobile because you're going to power your project by the little battery on the bottom of that. So that is really neat. So you can go ahead and order your power board, and that'll make this whole project run a whole lot easier. Okay, so that is kind of an overview of things. Let me hop over here and let's see if we can talk a little bit about the schematic of how we're going to get this thing, this thing hooked up. So what I want to show you is, you see that we are using the power board, and then over here we're also going to have to plug in the USB cable so that we can download the code. But what I want us to do is I want us to try and focus on powering the project from the powering the project from the power board, and then we're just going to have the USB connected to download the code. Okay, does that make sense? So what I want you to see is, I want you to see how I have this. I want you to see how I have the Raspberry Pi hooked up over here. And what I want you to notice is I have right here, I have the pin 39, which is the Vsys pin. I have it connected to the power rail. Then over here on the power bank, I have it set to 5 volts, and it is going to establish this as the power line, which will be at 5 volts. And then here, this will be the ground line. So I have the Raspberry Pi Pico W hooked up to 5 volts from Vsys, and that should be able to run the Raspberry Pi Pico W. So even if I unplug the Raspberry Pi Pico W, I will be powering it from the power board there. Now, what's very important for you to see is these little jumpers. These little jumpers need to be connected in the 5-volt position. You can get 3.3 or 5 volts out of this depending on where you put those jumpers. We are running at 5 volts today. Okay, so getting this thing hooked up, we're going to be able to power it here from the power bank, and we're going to be able to run the project that way. Okay, what I need you to see is, let's look at this little IC here, which is the TA6586, and I need you to see that the little divot, there is a little divot, the little divot is here. Okay, and then what you remember is when you've got a little divot like that, and then you've got 8 pins or however many pins, it doesn't matter how many pins you have, but you put the divot up, you go to the left of the divot, and then that's pin 1, 2, 3, 4, around the horn, 5, 6, 7, 8. And so that is how the pins are labeled, and you have to see that my little divot is pointed to the right, and that'll let you hook it up right. Okay, so then what I have is I have pin 1 hooked up to, I have pin 1 of the IC hooked up to pin 14 of the Raspberry Pi Pico W, and I have pin 2 of the IC connected to GPIO pin 15, and then pin 3 is ground, and pin 4 is 5 volts from the 5-volt rail. Now the motor is going to go into pin 5 and pin 8. And you say, well, my motor doesn't have that color wires. Well, mine doesn't either. It's red and black on mine. But it doesn't matter which direction that you plug it in. Which direction you plug it in is just going to define kind of like what is the forward direction and what is the backwards direction. Okay, because they run forward or backwards. And if you reverse those 2 wires, it just runs the other way. So you've just got to kind of orient your code to how you have your circuit hooked up. Okay, does that sound good? I hope it does. So now let's just talk a little bit about how this motor controller works. You've got the pin 1 and you've got the pin 2. You have the pin 1 on the IC and you have the pin 2 on the IC. And then what do we know? We know that the pin 1 is connected to the Arduino pin 14, and the pin 2 is connected to the Arduino pin 15. Okay, if you want to go forwards with your motor, you put the pin 1, which is pin 14 for us, to 0, and you put the pin 15 to 1. If you want to go the opposite direction, the reverse direction, you put the pin 14 to 1 and you put the pin 15 to 0. If you want to be off, you put them both to 0. Now, just a little thing, and you couldn't see that because of my head, could you? Okay. Now, the thing that I want you to notice is that when I'm doing something with the motor controller, I always like to apply the signal to the 0 pin first. And so, like if I was off and I wanted to turn it on, I go up and I deliberately turn this off and then turn this on. Now, if I'm going to change direction, I would deliberately turn this off and then turn this on. So I always start with the off pin followed by the on pin, if that makes sense. Okay, so that's really pretty straightforward, isn't it? I think that's enough for us to at least get going with this thing. And so I'm going to come up and see if I can give you something to look at here. Okay, that should be good. And let me just do a tiny bit of Windows management. For some reason, these Thorny windows that I have are extremely hard to resize. Like I can't quite grab the edge of the box to resize it. And so it's endless frustration for me. Okay, so let's just look at this really, let me just say a couple of words again about how we have this thing set up. So right now this power bank is off, but the reason it's lit up is because the power is coming from the USB, and then from the USB, we are getting a system voltage from the USB, which is then powering up. It's then powering up this power rail, and then that's providing power to this that's making it turn on. Okay, but in a minute when we're going to be running the motor, we're going to try to disconnect the USB. But it really is kind of safe in the way that I have it hooked up. If you have the Vsys connected to this 5 volts, it is isolated from the USB, and so it's pretty safe to just leave this on. And then when I'm actually going to run it, I'm going to try to, as best I can, to disconnect the USB, because I just don't like a motor running and maybe sending something back up the old USB line and blowing out my computer studio. So it's just, I'm a little paranoid about running things like a DC motor in any way connected to the USB. Okay, enough of that nonsense. Let's jump over here and start coding. So this is really going to be pretty easy. We're going to say from machine import pin. That makes sense. You always need some timings. We're going to import time. I'm going to set up IC pin 1. That is the pin on the TA6586 pin 1. That is going to be equal to pin 14 on the Arduino, and that's going to be a pin dot out like that. Okay, IC pin 2 is going to be equal to pin, the method, pin 15 on the Arduino, pin dot out like that. All right, so now what are we going to do? We're going to say while true. When is true? True is always true. We just connected, we just created an infinite loop. I'm going to ask the user, what direction do you want? And I'm going to say input, which direction, like that. And then I'm going to give them their options. It can be F, which you might guess is forward, or it could be R, which is reverse, or O, that's the letter O. Those are the choices. O would be for off, right? And now, what do I want to do? Well, I never want to be in a situation where my code could go from full forward speed to instantaneously going in full reverse speed. And that would be sort of like driving your car down the highway at 70 miles an hour and throwing it in reverse. That can't be a good thing. So what I want to do is I always want to kind of turn the motor off before I do anything different. So I'm going to say IC pin 1. I'm going to turn it off like that. And then IC pin 2 dot off. That's going to turn pin 1 off, pin 2 off, and the motor off for sure. Now, if the direction that I just put in is equal to forward, okay, then I'm going to say IC pin 1 is off, because I always want to give the off command first, and then IC pin 2 is on, like that, okay? Now, similarly, if dir is equal R for reverse, then IC pin 2 this time is off, and then IC pin 1 is on, like that. Now, I don't have to worry about it switching directions from here to here, because it would always be up here first to turn it off. So I don't have to really worry about that. Now what I can say is if dir equal O for off with a colon, then IC pin 2 off, and then IC pin 1 off. All right. Could it really be that easy? Could it really be that easy, I ask? Well, let's see. Let's give you something to look at here. Okay, let's give you something to look at. And now we're going to run this thing. We're going to run this thing. Okay, and what is it doing? It's asking me for a direction. So I'm going to say go forward. All right, and then I will hit enter. Boom. Boom. And then I'm going to say go R for reverse. And you know what? That was very bad. And now let's see if I can get it to turn off. You know what? I needed to put a delay in here because I just did what I said we shouldn't do. So I need to put like a time.sleep. Let's give it a second to wind down there. Okay. So let's run this thing again. Okay. So we're going to say F for forward. All right. We're going to say R for reverse. And it is reversing. Okay. And then we're going to say O for off. I don't know. It's like the thing is trying to take off and it jumps up and down. And, you know, that thing is really running fast. And we could take the little propeller off and then it doesn't do that. But then we would have, then what we would have would be, you know, not able to really tell so easily which direction it's going. Okay, now I want to show you a little trick here. Hopefully you know this. I can come in here. Well, no, I was going to save this as main so I could run it with this disconnected, but then I wouldn't have a way to communicate with it where we are right now. Okay, I feel like we've had some early success today already. But let me tell you something. We can control the speed if instead of just giving an on and off to our input pin, the pin that we want to be going forward, instead of just turning it on, what we can do is we can apply a PWM to it. And if we apply a PWM to it, then what is going to happen is, if we apply a PWM to it, then what is going to happen is we're going to be able to control the speed. So there is actually very, very little of this code that we're going to be able to reuse. But what we can do is we do need to, besides pin, import PWM. And then what we're going to need to do is I'm going to need to create some PWM channels. So I'm going to have a forward PWM, and that is going to be equal to PWM of what I see pin 1. Okay, now you see, it's like I gave you a little truth table about the 1 and the 0, or the 0 and the 1, making it go forwards and backwards, and then we use pin 14 and 15 to pins 1 and 2 on the IC, and then we've got the way that we hook these wires up. So there's sort of like 3 different ways that each one of those could be done, and so it's just like hook it up. And if you don't like what you call forward, if you don't like what it's doing when you called it forward, then just, you know, reverse those 2 wires. Okay, because I don't know what forward direction is for a motor, really. Someone's going to leave a comment down below. Well, according to ASME spec 3745 counterclockwise. Okay, whatever. Okay, so we're going to go on. Reverse PWM is going to be PWM, and it's going to be IC pin 2, like that. Now we got to set the frequency, F PWM dot frequency of 1000 hertz, because that works pretty well. And then we're going to do a reverse PWM dot frequency, and that's going to be 1000 hertz. Okay, now this is the problem when we really start working with this program. What the problem is with PWM, you can kill the program, but it doesn't always kill the PWM. So you can stop the program and then the PWM continues, which means the motor keeps running, and it turns out to be very, very annoying. So we need to cleanly exit the program. And really, in almost anything you do, it's better to try to cleanly exit the program. So how do we do that? We do a try, and then we do down here an accept. Okay, so you try something, and if it works, great. And then if it doesn't work, you fall down to accept. Okay, now there's all kinds of different accepts, but what do we want to accept out on? Keyboard interrupt. And be very careful with your capitalization down there. So it's going to be in the try loop until you get a Control C, or if you come up here and tell the program to stop. And when that happens, it'll hop down here to keyboard interrupt. So I'm going to go ahead and do this. I'm going to have it print. So this will help us debug program stopped by user. Okay. Then I'm going to set the rpwm.duty unsigned 16-bit to 0. So I'm setting the duty cycle to 0. That will turn that pin off. rpwm.duty. No, this would be fpwm, the other pin, underscore unsigned 16-bit integer, and that's going to be a 0. Okay, and then you see they're not lined up, so I can see that something happened. I left my Y out there. So I set those to 0. Then I'm going to give them a chance to get that all situated, so I'll just say a time.sleep of 0.25. Okay, and you know, when we are doing projects and programs and we hit stop and we think everything's good, there's no telling what's still running, but it's just we don't notice it because it's not a loud and annoying motor. Okay, now what we're going to do is RPWM. Now that we've stopped it, we're going to de-initialize it, de-init. And if we did that for R, we don't want F to be left out, so we will de-init her as well. And then we are going to, that looks good. Now, this should just be a normal pin. So just for good measure, I'm going to say off. Okay, and then I see pin 2, which should just be a normal pin now, off. And that sounds like overkill, but really it's sometimes very hard to get these things stopped. So now that is the try and accept. Now your normal program is going to be here in the try. And so what I'm going to do is I'm going to say, what do I want to try? I want to just make my main program now while true. When it's true, true is always true. We just created an infinite loop. Now I'm going to go for speed in range of 20 to 101 in steps of 10. Now, what is that nonsense? What you know is if you've used these motors before, if you just apply like a very low signal to them, they won't start. They'll just kind of like that. And so you've got to get a certain level of signal for them to kick on. And so 20 should work there. So what I want is I want to go from a value of 20 to 101 in steps of 10. Now, what do you know about the duty cycle? If the duty cycle is 0, the motor is going to be off. If the duty cycle is 100%, the motor is going to be full speed. And we want to kind of scale between those, but I want to start at 20. So on that first application of the PWM, it'll actually come on. Now, let's think about how we turn that into a PWM signal. Well, first, we want this to be forward, so the reversed PWM pin is going to get a duty of duty use 16 of what? Absolutely nothing. He gets a 0. And then FPWM dot duty underscore use 16. Okay, what does he get? He is going to get the speed that you just set divided by 100. So this is like, 100 would be a 1 and a 0 would be a 0. Does that make sense? 100 would be 100 divided by 100 becomes a 1. So we're going between 0 and 1. We're just scaling that. And then we've got to multiply it by what is full scale in PWM. Well, if you want 100% PWM, you need to put a 65,535, which is a rather unusual number, and I won't take 5 minutes to explain it. Okay, So speed of 100 would be 100 divided by 100, which is 1 times 65, 535. That would be full speed. If I had a 50, 50 divided by 100 would be 0.5 times 65, 535. That would be 32, I can't do it, 32,750 or something like that. And that would be a 50% duty cycle, and that would be half speed on the motor. And then what I'm going to do is I'm going to put a time dot sleep of about 0.25 seconds, just so it's, the for loop can go really, really fast, but the motor can't turn on and off that fast. So we're going to slow this thing down so the motor can keep up. Okay, so that is good. So we've gone from off to full speed, and now I kind of want to do the same thing, but I want to go from full speed to back to off. So I'm not changing the direction. What I'm going to do is I'm just going to here, though, I'm going to go from this time, I'm going to go from 100, and I'm going to go from 100 down to, this time I want to go all the way to 0, and I'm going to step in -1. So on the downside, I want to go to where I've actually stopped the motor. All right, I hope that makes sense. And then this stuff should be the same. So now what I think I'll do is I will put in a time dot sleep of, let's say, 2 seconds. So it should go slow to fast, fast to slow, and then it should be off and it should pause. Okay, so let's see what happens. What does that say? It doesn't like IC pin 1. I had an error last time. IC pin 1. I have some strange remnant error, and it does not make any sense to me. Okay, let's go ahead and run this thing again. Can't convert float to int. Oh yeah. So on this speed, that needs to be an integer, because you can't have a duty cycle of a non-integer number. So we need to make that an int open. And if we're going to open, we are going to need to close. If we're going to open, we're going to need to close. I think so. And then same thing down here. We're going to int open and then close. Okay, so I think this should run. So all eyes on the motor. It's winding up full speed and then winding back down. And okay, but the strange thing is it really didn't feel like it stopped, did it? Okay. So now this is the real question, is does all this nonsense work? So let me see if I stop it. Yeah, boom, I stopped it. Now why did that? I took this all the way down to 0, all right, and then I said rest for 0.25 seconds, and then I said rest for 5 seconds, but I did not see that 5-second rest in there. I really did not see that 5-second rest in there. So that 2-second rest. So let's make it 5, and certainly we should see that. Okay. Okay, it stopped, and now it's going back up. Okay, I've got an error in here somehow. That is just not doing at all what I think. Okay, so I'm going from 20 to 100. And then I'm going from 100 to 0. You see, I'm just not seeing this sleep in here anywhere. This is a kind of a perplexing problem, isn't it? Let me just put a 15-second. So this thing should ramp up, and then it should ramp back down. Okay, it's ramping down. It's like it's never quite going to 0. You know, it's never quite going to 0. So it did stop there, but let me, you know what I'm going to do is on this downside, let's look at the print, what we're applying there. Because you see, it's not even, it doesn't even sound like it's completely stopping. Okay, do you see what I'm saying? It's like it's not completely stopping. So let me come over here, and I want to see what that thing prints out. Okay, you see it's coming down, but that number did not go to 0. That number did not go to 0. And you know why it didn't go to 0? It didn't go to 0 because I stopped at 0, which means it's going to stop at 1. So I think that needs to be a -1, and then it should go all the way to 0 and stop. Okay, let's try that. Okay, there. And now I think if I go back and put a 2 in, it should work. Okay, and stop and start. Okay, that is looking really good. You see, I think that is, I think that's working. I think that's working correctly. So it goes slow to fast, fast to slow. That's what we want. And then also, if I stop it, all of this nonsense down here does stop the motor. Now, what I want to do is I want to take this, and after the 2-second stop, what I want to do is I want to put that in again. But this time, what I want to do is I want to go backwards. So then what would be the forward would be 0, and the forward, how did I get my caps lock on? What is that? Okay, the forward, and then this is going to be the reverse, and this will be the forward, and this will be the reverse, like that. Okay, so let's see if that works. So we really want to see if we can control the speed. We really want to see if we can control the speed. Ramping up to full speed, ramping down to 0, waiting, going backwards. You see in the backwards direction, the motor doesn't jump around. Forward, fast, slow, stop, reverse, fast, slow. Okay, guys, we have this thing working. Now, on this one, let me show you a little trick. Let's see if we can stop it here. Okay, now I've stopped it. Now, what I want you to see is that this chip is getting power not from the Raspberry Pi Pico W. This chip is getting power from this rail, which is established by the power bank. And so as I'm doing this, I'm getting power from here, and then this is just being used for communication. So I'm powering from this, and I'm just using this for communication. But if we come over here while we're still connected, let's come over here and let's do a file save as. And what we're going to save this as is main.py, like that. Okay. Yes. Alrighty. Now what I'm going to come over here is I'm going to turn this off, and I'm going to unplug this. Okay. Now what I want you to see is I want you to see that we are completely mobile, and now I'm going to turn this on. Boom! Okay, look at that, guys. That is really, really super swift. So you see why I like these little power banks so much? I've got a little box of them because I like them for all my projects. I really like using them for all of my different projects. I see that as that motor really cranks up, that this is starting to kind of dim. And I'm wondering if maybe I didn't start with a completely charged up battery. But I will say that those little motors can drain your battery pretty quickly. And I probably didn't start with a full charge. So the other thing you can do, if you have a 5-volt DC wall wart, you know, one of those little converters that puts out 5-volt DC, you can power this thing from that, and then you won't be mobile, but you'll absolutely be able to run this thing for as long as you want. Okay, time for us to talk about homework. So what I want you to do is I want you to generate a PyQt widget. And what that widget I want you to have is I want you to have a on button. I want you to have a forward button. I want you to have a reverse button, and I want you to have an off button. And then I want you to have 2 slider bars. I want the one slider bar to be the speed in the forward direction, and then I want the other slider bar to be the speed in the backwards direction. And then I want you to be able to go from forward to backwards to off, or off, backwards, forward, whatever direction you want. But all of that in a nice graphical little window, and then you are running your motor remotely. You could put the project anywhere in your house that's within your Wi-Fi range, and you could make this, make this thing work. So it's got to be a PyQt controlling it, and you've got to be communicating using UDP over Wi-Fi. And I've shown you already how to do that several times. You can go back and look at the lesson from 3 or 4 weeks ago about how to pass data over Wi-Fi using UDP. And so that is going to be your homework assignment. Okay, guys, I hope you're enjoying taking these classes as much as I am making them. As always, I want to give a great big shout out to you guys who are supporting me on Patreon. The types of advanced lessons that I'm doing do not get millions of views. They get a few thousand views. The only way that I can make this type of content is through the support of my Patreon. So thank you. You can also help me by giving a thumbs up on this video. When you do, also leave a comment down below. I want to remind you, if you haven't already, subscribe to the channel. And when you do, make sure you ring that bell so you'll get notification when future lessons drop. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.